Okay, hello guys. So today I will show you how to generate missing data. So missing data, there is many type. There is three types of missing data. So let me share the screen first. So missing data, type of type of missingness. I don't know. So in missing data, actually we have three types of missing data. Uh, if we want to generate missing data for climate data, missing data imputation study, so we have like MCAR, MAR, and MNAR. So usually for climate data, we have this type of missing completely at random, which is MCAR. So for this purpose, I will show you how to do this. How to generate missing data by using MCAR. But what we are going to do is we want to generate missing data, additional missing data, because if you read other people paper, I try to show you based on this graph. So for example, people usually they have one complete data set, there is no missing data, and from this complete data set, they want to generate 25% of missing data. So they use generate MCAR, and then they generate 25% of missing data. So there is no missing data from the original one, and then they generate 25% missing data. So that based on this missing data, they can compare back with the original one. But in this case, in this our study, we will not do this kind of stuff, because this is kind of hypothetical only, because a lot of station they will have missing data. So instead of doing from 0% no missing data and generate to 25%, we will generate up to 25%. So the keywords here is we want to do uh, up to 25%, up to 25% missingness. So for example, we have original time series data. For example, here from 1 until 20, the original data already have 10% missing data. So from 10%, we want to generate additional 15%, so that it will become 25%. So when we generate this missing data, uh, additional up to 25%, the original missing data will be retained, and then we will create additional missingness by using these three. There is other additional 15%, so that it will up to 25%. So by doing this way, we can compare original missing data, which is the real data, compare with the generated 25%. Instead of doing like all other paper, they usually do original data, that is sometimes they use artificial artificial original data to compare the method, or they try to find the period that have all the data, complete data set, and then generate missing data. So it's very difficult sometimes, because sometimes we don't have a complete data set. Sometimes missing data is random, sometimes it's continuous. So there is many issue. So so I'm thinking that if we can just retain the original data set, and then if we want to generate up to 25%, we can uh, generate additional missing data for this data set. So this data set will be imputed by different method, by using mice package or miss forest or something like that. You can impute it by using the same different method, and it can still comparable. You can still compare that performance. Uh, Compare the performance with the original later on by using performance statistical metrics. So this is the idea on how we want to generate missing data, which means we are generated additional missingness. So before we generate missingness, so in this case, you can refer to my paper here, evaluating imputation method for rainfall data under high variability in the River Basin, Malaysia. So in this paper, for these purposes, you need to go to table 2. This table 1, table 2. You must list first. Previously, I already show you how to do analysis of missing data, how many missing data for each station. So you must list all of this station, how many station, how much is missing data for each station, and how many station have less than 5% missing data, how many station have 10% missing data, and 20% or 30% or 40, 25 is up to you how many percent you want to do for your analysis. So, for example, I have for 5% missing data that I can generate up to 5% is only like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, only 12 station, which is sufficient for me to compare all imputation method. So I can have compare this 12 station only for up to 5%, because not all station have less than 5% missing data, right? Some station have more than 10%, more than 5% missing data. So there is, you can list all the station that less than 10% here, so that only this station you can generate up to 10%. Only this station you can generate up to 20%, and only this station that you can generate up to 30%. You see, for 30%, almost 20% and 30%, almost all station already you can do for 20% and 30%, because most of the, in my case, most of the station have less than 20% missing data. So it's up to you how many missingness that you want to add. So, but make at least this first, because later on in the code, we want to generate missing data. If you put, if you want to generate missing data for 5%, but the data is already have more than 10% missingness, it will not calculate correctly. You must input for up to 5% for station that has less than 5%, uh, up to 10% that station have less than 10%, and generate 20% additional missingness for station that has less than 20% missing data. Okay, I hope that clear. Now I will show you the code how to do that one. So the first one just now, the first step just now you must prepare station data missingness. So you can refer to table 2 in this research manuscript. So this is the link. I will show you here. Okay, I put it there. You can refer later on. So this is how we want to generate missing value. But in this case, we are only using MCAR, because MCAR usually climate data that the type of missingness is MCAR. Because but if you want to do more comparative assessment in other type of missingness like MAR or MNAR, do let me know, because I think this is already quite extensive. If you want to compare different method, and then different missingness, and then different parameter, and then different predictor, either using rainfall only or using other variable. So that is a lot of analysis that you will do. There's so many decision tree already. So I think it's better to stick with MCAR, which is relevant in this case for multiple parameter analysis. But if you want to do more, just let me know. So the library that you need is a library miss method. So you need this miss method. And then you also need library ggplot2. And then set seeds 1 to 3. And then just follow this code, make simple mdplot using these functions. Because this is the, let us, what is this? Usually if you have any question that you don't know, you can just ask ChatGPT. What is this code? I think that this one is just to generate artificial missingness. And make simple MD plot. Oh, this is for plotting actually. But doesn't matter. You can just run this code. It doesn't affect anything. So as usual, we go to our set working directory. So our working directory is here. So we will use this is for example. This is for example. I have hourly rainfall data for Sarawak, 1999 to 2018. So let's see. Okay, here. Uh, for Sarawak, it's quite big, 34 megabyte because this is hourly data. So, okay, this is my data set. So actually, I already have ranked everything, all the station, which data set have 5% missing, less than 5%, less than 10% missingness and everything. So that easier for me to do later on. I have jotted down. So I have identified, for example, station 100 1008 So for uh, this station, you see this station actually has less than 5% missing data. So I will generate, if we look the original data set, uh, let's do this. Uh, eh, we can count it, count, count NA. You can just count NA, and then and then I oh supposed to be counting NA. Let's see if we can find NA. Oh, it's not going there. Maybe count if. Oh no. Oh, there's no missing data for this one. Let's see. It's not counting. Anyway, for example, for this station, we have still. I want to see actually. Let's see a station that I use for my previous RCCE. So I have this this daily data. So we will not use this hourly data. It's very huge. Okay, we have this data set 1970 to 2015. So let's copy this data set, put it here. We will work with this data set. So for example, this data set, if based on my previous study, station 15387. So in this station data, 1538117. Okay. So here we can try count on the missing data in this data set. Okay, so it's actually counting the number. So we can do equal to 16801 minus this value. So we have 123, 123 minus 123 minus 16801 times 100. So for example, here we have 0.7. This is, we have 0.7 missing data, 0.7% missing data. So here, for example, this station, right? We have 0.7% missing data. And then from this 0.7 missing data, we want to generate 5% missing data, right? So we want to generate 5%. So additional missingness that we want to generate is actually, uh, why is it should be number? Okay, okay. So we want to generate, so 5 minus 0.7. So this is how much missing data we want to generate for this station, which is 4.3%. We want to generate 4.3% additional missingness for this data set. So by using this code just now, so we read this data, set working directory, this example station just now, Joe River Basin, and then first you need to count the length of that station just now, because we want to calculate additional missingness. This is the calculation to calculate how much you want to calculate additional missingness. So by using this equation, you don't need to calculate one by one anymore. You just use this equation for all the station. All you need to do is you need to select which station you want to calculate and generate additional missingness. So here you can use this equation, get the length of that station first, and then count the number of NA, sum it, and then this is the equation. So here you can change, either you want to change to 5 to 100 is equal to 5% missingness. So if you want to 10 over 100 is equal to 10% missingness. So the equation here that you need to change, if you want to create additional missingness, 10% change here. If you want to change to 15%, change here. So put it here, add, and then this is the delete MCAR is this function that will calculate, that will generate missing data, but it will generate additional up to 5%. So we can view here what is add just now. So as you can see, it will add 4.3% of missing data. So 4.3 additional missingness based on this equation that I used just now. And then you generate missing data by using delete MCAR, which is generate missing data based on MCAR. So use this equation, and then okay, now you have your result. So this is will be this station. So you must do one by one, one by one. So based on MCAR, this station and 5%. Okay, now it has generate the missing data. 5%. Okay, here. So this is your result. So here you will have, if we use the last equation, you see, it's sometimes it's generate a little bit higher, 0.7, because it's considered the length of the data set. Oh, no. It's must here we can yeah, right. Because sometimes it's consider the length of the when we do this equation. When we do this equation just now, it will consider how when calculate is close to 5% as much as possible, because it's maths, it's mathematics. It's if you 3 minus 1, you still get 2, but you will cannot get as close as possible to 5% sometimes when you do calculation. But some time series it will get very close to 5%. Some station will very close to 5%. Some station very it will very close to 10%. Not sometimes it's exactly 10%, but sometimes it's very close to 10%, something like that. But you can use this to calculate generated missingness. So each station will have the same missingness, and that same station you can use a different method later on to for missing data imputation. So this is the next step to for missing data research. You must generate missing data for by using MCAR, and up to how many percent is up to you. So I think this is how to do it. Later on, I will show you the next step. The next step will be imputation, itself, because generating missingness is also uh, maybe take some time. But I will show you how to generate missing data by using mice package. Mice package is quite simple, so we will continue with that one directly.